Okay, chapter 6 of MYP4 unit 1 was completing the square. So I gave this example, x plus 2 all squared equals 10. So it's not quite in the form we're used to seeing when we solve these, but one way to solve it could be to multiply it out and make it look like one of the ones that we're used to. So we did that. So x plus 2 squared equals 10. I multiplied that out, so x plus 2 squared means that bracket times itself. And that gave me x squared plus 4x plus 4 equals 10. And then I took 10 from both sides. And now that looks like one of the ones that we're used to, with an x squared, an x, and a term on the end. So we made those our values of a, b, and c for using the formula. So a was 1 because we had 1x squared. B is 4 because we've got 4x, and then we've got minus 6 on the end, so C is minus 6. So I stuck all of those values into the formula, being very careful of the minus signs, and I got a couple of values at the end, which were, as it happens, quite horrible values that weren't nice round exact numbers. But there's another way I could have approached that. So because the left-hand side was something exactly squared, x plus 2 squared equals 10, I could have just taken the square root of both sides and said, okay, so the bracket on its own is the square root plus or minus of 10. I've just square rooted both sides to get x plus 2 is the square root of 10. And then I can just take away 2 from both sides to get the x on its own. So x is minus 2 plus or minus the square root of 10, which when I worked it out gave me the same answers as before, but in a much shorter way. So there's an advantage to be gained if one side of the thing you've got happens to be a perfect square. And the method called completing the square is all about doing that. So I've written we could manipulate other quadratic equations in such a way that we obtain a perfect square on the left-hand side, so that we could then solve them in that way. And that method is called completing the square. So I gave out a whole sheet for that, which had a menu for that, and I'm just going to have a closer look at that now. So here is that sheet that you should have had a copy of in class. Zoom in here. There we go. So I gave you a step-by-step recipe here. So the first step was to divide, if necessary, so that the coefficient of x squared is 1. So here the coefficient of x squared is 2. We've got 2x squared. So what I've done is just divide everything both sides by 2 to get x squared instead of 2x squared, 5x instead of 10x, minus 1.5 instead of minus 3, and then on the right hand side it's still 0 because 0 divided by 2 is 0. So I've divided both sides by whatever it took to get a single x squared term, in this case 2. Right, step 2, rearrange so that the constant term is on the right. So at the moment I've got x squared plus 5x minus 1.5 equals 0. And then I've just added the 1.5 to both sides, in this case, to get x squared plus 5x equals 1.5. So that's all about getting all of the x's on one side and all of the regular numbers on the other side. Step 3, add half the coefficient of x, comma, squared. Now you've got to be very careful to read that the right way. This is the one step that most people do wrong, most commonly. So it says add half the coefficient of x. So the coefficient of x is 5, and then you square it. So the coefficient of x is 5. Half of that is 2.5, so that's half the coefficient of x. And then we square that to get 6.25. So we add 6.25 to both sides. So you could very easily misread that as being the coefficient of x squared. So the coefficient of x being 1 and then 1 squared. It's not the coefficient of x squared, it's the coefficient of x and then square that. So be careful with that. Okay, so in this case, that turned out to be 5. Half it is 2.5. Square that is 6.25. We added 6.25 to both sides. So that gave us x squared plus 5x plus 6.25 equals 7.75. Now that doesn't look like we've made any progress because it doesn't look much simpler than the thing we started with. But the advantage of that is that that process has made the left-hand side into a perfect square. So you can write x squared plus 5x plus 6.25 as x and something else in a bracket all squared. So the left-hand side is a perfect square. Factorize it is the next step, step 4. So that thing can be written as a perfect square, x plus 2.5 all squared. Now how do we know it's 2.5? Well, there's two ways we know it's 2.5. We could get the 2.5 from the square root of 6.25, because we know that 2.52 has got to be multiplied by itself to get the 6.25. Or we could get the 6.25 from half of 5, because we know that when we write that as two brackets, we're going to get an x times 2.5 and then another 2.5 times another x, making 5x. So it's two very simple ways of getting the number in the bracket there. The square root of the number on the end, or half the number in front of x. Okay, so we've got x plus 2.5, all of that squared equals 7.75. We can square root both sides to get the bit that was in the brackets on its own. So instead of x plus 2.5 squared, just x plus 2.5. And then because it's an equation, we've got to do exactly the same thing to both sides. So we've got to square root the other side as well. So instead of 7.75, the square root of 7.75, which should be plus or minus. In fact, I've not put plus or minus on there. I should have done. Okay, so we've got x plus 2.5 equals the square root of something, and then we just get the x on its own by taking the plus something away. So in this case, plus 2.5. So x is minus 2.5 plus or minus the square root of 7.75. Okay, so that's how we did it for that particular example, but you can apply this 6-step program to any quadratic and solve it by completing the square. So you're essentially completing a square on the left-hand side, you're making the left-hand side into an exact squareable quantity. So here's a question for you to try. Solve 4x squared plus 8x minus 21 equals 0 by completing the square. And then it says leave your answer in surd form. Surd, you might see referred to as radical or square root. Basically means leave the square roots in it rather than turning them into decimals. So pause the video, have a go at this, and here comes the answer. Okay, so step 1, divide by something to make the coefficient of x squared 1. So at the moment I've got 4x squared plus some other things, and I've divided everything by 4 both sides just to get a single x squared. Then the next step was to add the 5.25 to both sides to separate out the x's from the other numbers. So I've added 5.25 to both sides, and I've got all of my x's on the left and 5.25, a regular number, on the right. Okay, this is the tricky bit now. Add half the coefficient of x squared. The coefficient of x is 2. Half of 2, 2 divided by 2, and then square that, comes to be 1. So I'm adding 1 to both sides. So when I add 1 to both sides, I get x squared plus 2x plus 1 equals 6.25, because I've added 1 to both sides. And then the good thing about that is that the left-hand side is now a perfect square. I can write it as x plus or maybe minus something all squared. And I get that number that goes with x in the brackets in 2 possible ways. I can either say it's the square root of 1, or I can say it's half of the 2. So 2 possible ways for me to get the number in the brackets there. Okay, so I've got x plus 1 squared equals 6.25. So I can square both sides, square root both sides to get x plus 1 on its own is the square root of 6.25 plus or minus, and then to take away, and then to get the x on its own, I took away the 1 to get x equals minus 1 plus or minus the square root of 6.25. And you work that out and it's fairly neat, 1.5 or minus 3.5. But in fact the question did say leave the answer in surd form, so you don't even need to get that far. Now you wouldn't normally be asked to solve quadratic equations by this method in most exam questions these days, but completing the square is important because it's how we get the formula. So if you start off with the general quadratic, ax squared plus bx plus c equals 0, and you do the process of completing the square on that, you can get it with careful algebra to boil down to x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So in other words, completing the square is important because it's where we get the quadratic formula from. Here's another one. Solve 2x squared plus 15x plus 22 equals 0. Pause the screen, have a go at it. And there's the answer. So here's my proving the formula. I'll just leave it on screen. You can pause if you're interested, but you can see it all boiling down to minus b plus or minus square root b squared minus 4ac all over 2a.